Alright, hell yeah. So I've spent about a week on this problem, and it was cool because I was just ready to do the calculus, and I got it wrong, because it's just really easy to make simple errors. And then I just knew that I could just throw this into Excel, and it just makes so much sense. And so we're going to walk through the math, and this shouldn't be too long of a video. Hopefully it's, hopefully pretty tolerable. But the general gist is that gravity, and I love these test problems where they just say gravity is 10, because then you can drop something off a cliff. Every second it's going to be, after 1 second it's going to have 10 meters per second in speed. But it started out at 0, so the average velocity is going to be 5 meters per second for that 5, so in 1 second it traveled 5 meters. But in that 1 second it is now at 10 meters per second. So even if this cliff is 500 meters, we can kind of just guess that, hey, what happens after 10 seconds? With this acceleration, I'm going 10 plus 10 plus 10. I'm going 100 meters per second. 0 meters per second. After 10 seconds, 100 meters per second. Average speed of 500 meters per second for 10 seconds. I apologize. I said that wrong. We're going to increase our velocity by 10 meters per second every second. So in 10 seconds, I'm going to be going 100 meters per second. I don't know what I said. I might have said 1,000. But after 10 seconds, I'm going 100 meters per second. I started at 0, and that is a linear change in velocity. So my average speed is 50. So velocity average is 50 meters per second. If I did that for 10 seconds, hell yeah, I'd go 500 meters. So the time to hit the ground is going to be 10 seconds. So that's kind of the first part of this, is just to have like a general gist of what's going to happen with things falling towards the earth. Hell yeah. Okay, so this gets tricky because we do have air resistance. And let's just start with the more complex, because that's where I jumped in. I was just like, well, hell yeah, let's do the y direction. Okay, so in the y direction, we're going to have the acceleration in the y direction is going to be gravity. And I'm just going to say g is a positive 10 meters per second squared. But when we use gravity, we have our coordinate system here. So I'm going to say this is the negative direction. And so we're going to be accelerating in the negative direction. So we have a negative g right here. The air resistance is, they say this is the motion due to air resistance is going to be c times velocity. And c is going to be inverse seconds, and velocity is meters per second. And so this gives us units of meters per second squared. So this is acceleration. So air resistance is going to affect acceleration. And so if we have negative 10 down, air resistance is going to slow that up. Okay, so this is where I made my first error. I was just like, well, if this is negative, the air resistance must be positive CV. So this was the huge red flag moment that, well, what's your input going to be? It's a function of velocity. We're going to pick up negative velocity. You know what I mean? Because we're going to be in the negative direction. And so if this becomes a negative velocity, c is just a constant of 0.05, then it'd be a negative and a negative. That means that we're going to be accelerating, where the whole gist of this problem is air resistance is going to be proportional to your velocity. When we drop this off, or if you jump out of a plane, you're going no speed. There is no air resistance. You jump off a pretty large cliff, 50 foot, 60 foot cliff, into water, you ain't slowing down due to air resistance, literally whatsoever. Because you need velocity first to actually have that change. I mean, your acceleration is going to be the same every second. 10 meters per second every second. Okay, so hell yeah. So when we do, after 1 second, we're going to be at negative 10 meters per second. And now we're going to pick up, and c is going to be 0.05, that's 1 divided by 20. And so if we go negative 10 times 1 divided by 20, we're going to have negative 0.5. And so if our acceleration was going to be negative 10, and we said now we're just subtracting a 0.5, well, that means that we're actually going faster due to air resistance. So that was the first place. So this needs to be negative 10 plus 0.5. And the only way to get this whole thing to be a plus is if this becomes a negative. Negative minus, negative minus, whatever. Two negatives become a positive, however they say that. So hell yeah, so this is our equation. Acceleration in the y is negative g minus cv. But that threw me for a loop for like literally 2 days straight. Okay, hell yeah. And now you're just good to go, because this is acceleration is change in velocity, change in time. And at this point, I'm going to drop all subscripts. You know, I could put a y right here, but hell no, we're just going to drop all subscripts, because we have the y direction. Cool. And we need to separate variables. We're going to get the dt up here, and we're going to go dv divided by negative g minus cv is equal to dt. Now here's where I can slow down. I mean, you want this to look like du u. I mean, because we're going to integrate this. We're going to integrate both sides. This becomes a time plus a constant, and this hopefully becomes some sort of function of velocity. But we want to make it look like this. So we're going to do u substitution. Our u term is negative g minus cv. And then we're going to go take the derivative of this with respect to v. So that's du dv. Hell yeah. And you could even write it like this. Derivative of negative g minus cv. The more you write things, you know, like the more you do, I think it can help explain what, you know, it's like, hey, when we change, I don't know. But at the end of the day, we still just have to use the rules of derivations and the rules of integration. Anyway, so to derive this is a constant that goes to 0. This becomes negative c. So the derivative of u with respect to v is just going to be negative c. In our integration equation, we have a dv. We don't have a du. So let's solve for dv. dv comes upstairs, negative c comes downstairs. And I suggest, you know, even just do that. Just get the dv up here, and then get the negative c down here. And then even make this look better. dv is going to be negative 1 divided by c du. I mean, you could even write it as dv is negative 1. 1 divided by c du. And then I think it just makes it, I don't know, like not hocus pocus, because you literally are subbing this into that dv, and then you're saying this is u. Yeah, we get that's u, but what the hell's dv? dv is all this stuff. Cool. So we're going to have so dv is going to be negative 1 divided by c du. Finally, we got the du. Divided by u is equal to integration dt. Hell yeah. Alright, so now we have constants. We can just get those outside. We can do that negative 1 divided by c outside the integration. And now we just have it bare bones. You know what I mean? And then this is going to be integration dt. I can get this to the other side, and I would do that. Du u is equal to, let's get this to the other side. That's going to be a negative c. It's a constant. It's outside the integration. All right, now we can just super easy integrate. This is just natural log of u is equal to negative ct. All right, what the hell's u? So now we can plug u back in. That's going to be negative g minus cv is equal to negative ct. And we pick up a constant. Now, the constant is when time is 0, or it could be any time that you know something about the problem. But at time 0, we're in the y direction. Our velocity is 0. So that becomes 0. Just that part. This becomes totally 0. And then we have c1 is equal to natural log of negative g. Alright, booyah. So now we're going to move on. So now we have natural log of negative g minus cv is equal to negative ct plus natural log of negative g. So now we need to solve for this v. And we do that, and mathematically and arithmetically, you can get this natural log. I mean, I'm sure you can do a lot of different things. That's where I was running into issue at the very fundamentals of making this a positive. That really messed me up. But anyway, if I subtract this, we'll just do this long form. So if I do this and subtract this from this side. Alright, so now all I did was get this to the other side. When you have natural log minus a natural log, it is the same thing as natural log negative g cv divided by negative g. That is essentially what you're doing. You can put them in brackets, whatever. Nothing else has changed. That's all we did is just say that the natural log minus a natural log is, and if it was plus, we could just multiply them. But hell yeah. Now we can take e to both sides, and this goes away, and we have negative g minus cv negative g e to the negative ct. This is going to be a 1, and then a plus cgv. Cool. Now I'm just going to subtract 1 over here, and then we're going to multiply, and then to get this by itself, I'm going to multiply by g divided by c both these terms. So we have a g divided by c e to the negative ct minus g divided by c. And booyah, we did it. We have our velocity. Well, actually, that was just the first step. This is velocity as a function of t, and I'll put the subscript back in, of y. And so now, and like I said, we're doing the hardest one first. So cool, we know that velocity is a change in position, change in time. Since this is in the y, we're going to have a change in y, change in t. And then we have that is this equation. Cool. Separate variables. We're going to get this dt over here, and then we can integrate. And this dt is spread between, we have 2 integrations, and we could do that, you know, whatever's clever. So this is going to give us y as a function of t. That's the integration of dy. And then, you know, this is just going to pick up a t, that integration. What we have here is another u substitution. U is going to be negative ct. Du, and then in this case it's going to be dt, because that's what I have right here, is going to be negative c. So let's get dt by itself. So dt, get it upstairs, get the negative c downstairs, is going to be negative 1 divided by c du. Hell yeah. So now let's sub that right in. So we have integration, g divided by c, e to the u. We have a dt. That's going to be negative 1 divided by c times du. Hell yeah. And then let's just do this one. This is, well, now we won't do it yet. So we have the integration of gc dt. Now anything that's a constant, let's actually get that outside of the integration. So we have this is a constant, and this. Hey, we have 2 c's downstairs, and we picked up a negative. So we got negative g, 2 c's downstairs. Now we have the integration of eu du. That'll be pretty simple. Integration of eu is just eu plus a constant. Booyah. Alright, we do have constants here. G divided by c integration dt. Okay, so now the integration is going to be fairly simple. We are going to, this is just negative g c2. Like I said, this is just e to the u. So we have e to the u, and then we have this is gc, and then we pick up a t. Cool, plus a constant. Let's throw in our u value. That's going to be e to the, our u is negative ct, booyah, minus gct plus a constant. When time is 0, what do we know about the, what do we know about the y position as a function of time? And so, yeah, and hopefully I did that right, because on that one that we got the velocity, what did I say? The velocity, well, yeah, we said when time was 0, velocity in the y direction is 0. Now we're on position. This is a position, and our position is hella up there. In the y direction, it's our height. It's 500. It's capital H, I guess. I did lowercase h, but we can switch that. Hell yeah. So when time is 0 here, it's going to be 0 there. E to the 0, this whole thing is 1. And so this stands. So this becomes 0. This becomes, you know what I mean, just hanging out. And when I throw in this value of 0 for my time, my position needs to be h. Ooh, that's not h. There we go, h. It's not equal to h, so we actually need to cancel this out by adding a g divided by c squared, and then plus the h term. Hell yeah. So now this is our equation. For position, so that was y of t, we just did that one. Hell yeah. And that was the harder one to do. I'm just going to double check with my answers. And we have y as a function of time. Yep, hell yeah, it looks really good. Alright, so now we're going to do, hopefully, the easier direction, the x direction. So in the x direction, we still have air resistance, and then we have some sort of initial velocity u. That's what they want to use for the problem. Alright, hell yeah. Got some more juice going? Alright, so in the x direction, our acceleration in the x doesn't have a component due to gravity. If we have constant velocity, there really is, in an ideal, there is no slowdown. A mass in motion, unless acted on an external force, stays the same speed. You know, in motion, that same speed. But we do have the air resistance that's hitting. Air is little chunks of mass, and those are colliding, and hell yeah. So you do have conservation of energy, but you do have change in velocity. You're taking the velocity of this ball and making the air get out of the way. You know what I mean? Those air molecules were just chill, and then booyah, you just accelerated them. So equal and opposite forces. So booyah. So your acceleration is going to be, and our velocity is going to be positive x. So in this case, we're going to have a negative cv. Our velocity is going to be positive x, and that's going to be a u initially. Our initial velocity, vx initial, is u. And that's going to be slowing down every second because we do have a deceleration. Booyah. Alright, so this is going to be acceleration in the x is change in velocity in the x, change in time. And again, we're going to get rid of all subscripts just to make it hella easy. And let's separate variables. So we have dv. I'm going to bring this v downstairs. And then we have negative c dt. Hell yeah. And when we integrate, throw the integration sign right here. This is a constant. Throw the integration sign right there. So this is just super easy. Natural log of v. And again, this v is a vx as a function of t. After, you know, once we do this yes, this is a velocity in the x as a function of time. Yep. At any time, if I know the velocity and I put it in here, I will know the acceleration. Cool. Alright, so we have natural log of v is equal to negative ct, and we pick up a constant. I'll call this c2. When time is 0, we do have initial velocity in the x direction. That's u. So hell yeah. So when this is 0, c2 is natural log of u. Alright, let's write that out. So we have natural log of v is equal to negative ct plus natural log of u. We want to solve for this. So we need to get oh yeah, this is fascinating. I mean, you could just right now take this e to both sides, but we typically, oh, that's fascinating. I never even thought of that, but we don't do that. Like you could say this is e to the negative ct plus natural log of u, which yeah, no duh. But that is the exact same. It's just fascinating playing around with natural logs and seeing that that's identical. Because if you have 2 to the 2 plus 2, you know what I mean? What's that? Isn't that 2 to the 4? Isn't that 2 to the 2 times 2 to the 2? You know what I mean? Wouldn't that just be e to the negative ct plus e to the natural log of u? which e to the natural log just becomes, multiplication of that just becomes u. Check that out. Hell yeah. And so if I took e to the both sides, I'm just good to go right there. And then holy hell. Yeah, that's so fascinating. It's so fascinating that the third grade method is to subtract this. So we would go natural log v minus natural log u is equal to negative ct. But if you know what the hell exponents do, you know what I mean? If you have e to the exponents added, that's the same thing as e to the negative ct multiplied by e to the natural log u. That's so fascinating. And this just becomes u. Whoa, so that's just in one step. I never even thought of that. Okay, because this is the roundabout way. If you subtract these, then you have natural log of v divided by u is equal to negative ct. That's all we did. Now take e to both sides. You know what I mean? It gets rid of the natural log. We got v divided by u is e to the negative ct. We want to solve for that independently, so we have u e negative ct. Cool, I learned something during this video. Hell yeah. Alright, hell yeah. But this just gives me velocity in the x as a function of time. We want position. That's what it says. Obtain an expression for position in this direction as a function of time. And this is where I just gave u like a hella fast velocity. I gave it 100 meters per second. And this doesn't affect the time that it hits the ground. It's completely independent. And that is a function of like vector space, where you have, if I put a force in this direction, it means that there is zero force in the perpendicular direction. And if I do apply a force in the perpendicular direction, it doesn't affect this force in that direction at all. So the same thing with velocities. And so if I give this 100 meters per second, or just drop this thing, it's going to hit the ground at the same time. So hell yeah, if I said it was going to hit the ground in 10 seconds, and how far did it go this way? Without air resistance, it's going to go 1,000 meters. 100 meters per second times 10 seconds. With air resistance, it should be a little bit less. And given this value, we're going to have like 850. So those are kind of checks on reality that you can do. So cool. So we have this velocity as a function of time. And our velocity is going to be 100, and then it's going to start slowing down. And actually, right away, if this is 100, and we have our acceleration is negative cv, that's going to be negative 1/20th times 100. That's going to be negative 5. So in 1 second, this is going to go to 95. And if we keep doing that in 10 seconds times 10, that would go down to 50. But once we get to, let's say we just choose something. Let's say we get to 80. After 4 seconds, we get down to 80. Well, this changes. Negative 120 times 80. Now this becomes negative 4. So we don't go 80 to 75. We go 80 to 76. And then 72. So, you can kind of do a rough guesstimate of that. But for the most part, hell yeah, our speed at the end is going to be pretty close to 50 because we're starting with that value. So it's kind of equal and opposite. We're starting with speed in this x direction. Air resistance is going to slow that faster. Where in the y direction, we're not starting with any speed in the y. And so we're going to go 10, 20, we're basically going to go 10, 19.5, and so forth. Well, here, if we have 100, we're going to go 100, 95, 90, 85, and then just a little bit less as we go. So hell yeah. So we would expect our speed maybe about 60, maybe it's 54, with an average speed of still close to 75, or maybe 80. And so hell yeah, in 10 seconds, we'd be expecting to go 800 feet. And with air resistance in the y, we find that it takes a little bit more. It takes 11 seconds, or 10.9. That's kind of what we find. All right, so hell yeah. Now let's get back to the calculus. This is our equation as a function velocity in the x direction is a function of time. We want to say this is equal to the change in position, change in time, and integrate and separate variables. So we're going to say x is a function of time, is the integration of the change in x. U e to the negative c dt integrate. And same thing, we're going to have u is negative ct, du dt is negative c, solve for dt, that's going to be negative 1c du. Cool, so this becomes x of t is going to be the integration of u e to the u, dt is going to be negative 1c du. Hell yeah, so now we have our constants. We're going to have a negative u divided by c. These are our two constants, the negative c and this u. And then we have e to the u du. Cool. So this just becomes, it's the integration of e to the u is e to the u plus a constant. So we have e to the u, and then we pick up a constant. So I'm going to go plus. Oh, and that's kind of fascinating. Because this is a constant, I could do this. I don't like to do that. I'm just going to say e to the u, but plus a constant. I'll say that's c3. X of t, negative u, c. What is u? It's negative ct plus this constant. When time is 0, this becomes 1. And so we do have that. Our position in the x is 0, so we need to cancel this. So c3 becomes u to the c. And now we have x of t is negative u, c, e to the negative ct plus u to the c. And booyah. So where's our answer sheet? Maybe I should find that again. Alright, hell yeah. So here's my answer sheet, and these match up. So booyah. So we have found our x of t and our y of t. This is what we found. This is all that we have found. So we've answered part A. Holy Toledo. That's a lot of math and calculus. But now they want trajectory. I had to look up what the hell, equation for trajectory. Just because when you do stuff, you do like, hey, I want position as a function of time. I want position in the y as a function of time. But these are functions of time and are not representative of what you'd actually see. So I would say this trajectory, throw in eyeballs at like, hey, if you're on this field and looking at this cliff and someone throws this ball off, this ball gets launched off, what you're going to see is like what you'd see in a graphing situation. Like that's the path that you would see. You would say that distance is x and this distance is y. And so I don't know why that's, I don't know, but yeah, it's just the fact with trajectory problems, you're typically dealing with time, and a lot of problems don't get around to solving for what this equation would look like. What we have is just any 2 points, x and y, like those points. So here's over in the x, up in the y. And both of these are represented by 2 different equations. You know what I mean? Represented by those 2 equations. And both of these equations, x is a function of t and y is a function of t, both are a function of this time. And the time at that point is the same. So if I say that this is time as a function of this equation x, t of x, and this is t of y, I can say that t of x is equal to t of y is equal to t. So there you go. So at any, when, if this time, this time is equal to that time. And so enough said. So what we're going to do is we're going to solve this equation for this time value, and that is going to be time as a function of x and some other stuff, and we're going to sub it into this t. And I'll get rid of those subscripts, now it's hella confusing. There we go. So now let's solve this solve this for t. And this just becomes kind of the generic x. Hell yeah. So we have x minus u of c. That's all I did to get this to the other side. I'm going to factor out this negative right the hell away. So I'm going to do u to the c minus x. All I did is just flip those around. You can do that one. Hell yeah. I mean, let's just show you. If I do factor out that negative, I'm going to go -1 here. And then it's going to go -x plus u to the c. Just rearrange this u to the c minus x. Hell yeah. Hate negatives. Anyway, so hell yeah. So we got this to the other side. We got rid of the negative. And so all this is, you know, on the other side. We're going to get this to the other side. That's the inverse. Cool. And now we have e to the -ct. So we did all those 3 steps. Let's factor this through. C's cancel, u's cancel. This becomes 1 minus cu to the x is equal to -e to the ct. We want to solve for t. And so we're going to take the natural log of that, natural log of both sides. Sorry I did it like an exponent, not like an exponent. Natural log of this, natural log of this. So that just becomes natural log of 1 minus cux is equal to, that gets rid of the e, so we have -ct. And t is just going to be -1 divided by c. So hell yeah, there you go. So we'll write it a little bit juicier. So we have t is equal to -1 divided by c, natural log 1 minus cux. Booyah. Okay, so now we're going to plug this into this equation. So we have y is equal to -gc squared e to the -c. Now this is our t. So we have -1c natural log 1 minus cux. So this negative cancels that negative. This c cancels that c. That's done. Now we have e to the natural log. Those cancel. So now this is just multiplication of 1 minus cux. And I'm just going to do that. So hell yeah. So this is just our first term. But let's simplify it. So we have a -gc2. Foil this through. And then we have a plus g. The c cancels with one of those. So we have cux. Hell yes. That's our first term. Now we have a minus gct, which is going to be a -1c, natural log 1 minus cux. What do we have? Negatives cancel, and then the c gets doubled. So we have plus g c squared, natural log 1 minus cux. Hell yeah. And now we just have a plus g divided by c2, but that's going to cancel with that one. Hell yeah, and now plus an h. And I think they like to do the capital H for this one. So we have y as a function of x is g cu x plus g c2 natural log 1 minus cux. But you know what I mean, plus h. I'm just saying that I could never do this. I would never be able to get this the first time ever. You know what I mean? I make so many like nitpicky mistakes that it's just very difficult for me to ever just do the algebra 100%. So that's where you want intuition to be like, you know, run this in your calculator. And if it looks goofy as, you know what I mean? If you're not getting values that are, you know, y is a function. If I don't throw in 840 and get 0, you know what I mean? And throw in a value of 0 and get 500. You know, if I throw in 0 here, that's going to be the natural log of 1 is 0, and this is 0, so hell yeah. And then, you know, even just going back and be like, that was a refresher for me. Natural log of 1 is 0. And even a refresher of what the hell natural logs are. That's what I never want to do. Natural log is just log e, and if I had 1, this is equal to, and I do a box here, and what this is, base exponent. So I have e to this base to this exponent is 1. So this would have to be e to the 0 is 1. So so the natural log of 1 is 0. That's the exponent. I hate the form log xy is equal to, is that what they do? Log no, they do log base y is equal to x. Absolutely hate it. You know what I mean? Just log, you know what I mean? What you pick your base, you know what I mean? And then this is just a number, and then this is a box. There you go. So you have your e to the exponent is equal to your number. Hell yeah. That's, I don't know, I like it like that. Booyah. You know that's, I mean, you need to know that's your base for sure. Even writing it as b trips me out. You know, maybe it helps though. I mean, but if you call this b and this is x and y, x just gets overused in the math world. It's just like, hell no. But you can't call this e for exponent. I mean, you could call it exp. But hell, I just like to do a box. So then you have, and I've never written it like base to the box. Hell no. And just pick a number on that. So then if you have log base 2 of a number, box. This is 2 to the exponent is equal to the number. Hell yeah. So that's mine in a nutshell. Alright, so we did it. So we did the trajectory equation and we did it right. And so just to double check, that's y as a function of x. That's what it's going to look like. Alright, and then it says make a qualitative comparison of the trajectories. We're at 500 meters, and we get any sort of velocity. It's going to look like a upside down parabola. Is that what they're called? Yep. And what happens with the air resistance, it causes, if we have any sort of velocity in this direction, that velocity will approach zero. And, you know, with any decent air resistance, it'll approach zero within, 20 to 30 seconds. And I can even show you that. You know, like, where's our, what do we want? Yeah. Alright, hell yeah. So this is just a little tangent, but this is our velocity in the x direction. So let's write that in. So we have alpha u, and I have this at 100 meters per second. So u is going to be 100 meters per second. And then we have alpha e negative ct. And c, so c is that 0.05, alpha u is 100. And hell yeah, let's graph this. And and on this calculator, like you just throw in your x values. So we're going to go 0 to 11 seconds. And this is, whoa. If you do your x values, if you get your x values, all you got to do is go zoom fit, which is zoom 0, but it's zoom fit, and then it'll just perfectly fit your y's. So that's pretty sweet. So to start off with, we have 100, and then after 11 seconds, we're down to 57. So let's go for 100 seconds. You know what I mean? And we got to go zoom fit. So hell yeah. So this is after 100 seconds. And then let's go 100. Whoa, value of 100. Sorry about that, going a little fast. And our speed is 0.6, so our velocity is 0.6. Now, like, what would be 0? If I said I had a speed of 100, 3 significant figures, and then I said I had a speed of, I would say 0.6. That's pretty close. If this was 0.4, it would round down to 0, and then we would just be good to go. So hell yeah. So we're gonna go 200 seconds. But check this out, because it's exponential, or because it's logarithmic. Let's go zoom fit. After 200 seconds, let's check this out. So 200. Hell yeah. So now our speed is 0.004, and I would say that's 0.000. I would say that is legitified zero velocity in the x direction after 200 seconds. And you could, if you had this experiment in space and you had a force field, some sort of resistive force this way, well, I mean, this thing could go, it could go this way for an infinite amount of time, and just even after 200 seconds, it basically has zero velocity, negligible velocity. Alright, hell yeah. Alright, so it asks for the qualitative comparison of the sketches, so I would say parabolic shape without air resistance and with air resistance. What happens is that this slope approaches vertical, you know what I mean, and basically will become vertical. Because we lose velocity in the x direction. If we don't have any velocity in the x direction, We don't have any change in position, change in time. That's the definition of velocity. And so we just won't go that direction no more, and we'll be going, the graph will be straight up and down. It'll be a vertical asymptote, using my math words. But this will all be a parabolic shape. Now, as this goes to infinity, hell yeah, it'll appear to be vertical, but this will be more mathematically vertical than that. Hell yeah. And this becomes vertical, like mathematically vertical even after 200 seconds, where this still probably is more of a parabolic shape. Alright, hell yeah. So last question, what they wanted us to do is, given, you know, these parameters, the cliff height is 500, and, holy Toledo. I need to get my answers. So yeah, the cliff height is 500, C is 0.05, G is 10, and it says obtain an approximate time. What happens is that this is my position equation in the y direction as a function of time. So when my position is 0, cool, I'm going to get a value for t, but I got t in two different places. And so, and one is not negligible. Like these are both dominating the equation equally much, or, you know, kind of. Alright, so yeah, that sucks. So that's kind of like a trick question. You know, for this one it's worth 3 points. You might just say, hey, let's skip that, and if it just says approximate, just write 10 seconds. I mean, that's what it would be. So let's do that one first. If we don't have any air resistance, our acceleration in the y is negative g, or 10. And this is dv dt. Separate variables. So we have dv, is equal to negative g dt, and integrate. And so we get velocity is negative gt. And then this is going to be change in position, change in time, separate variables, and integrate. And we get position is, this becomes negative g divided by 2t squared. Because we get the power rule of integration. This goes to the t 1 plus 1 divided by 1 plus 1. That's t squared divided by 2. So that's what we have. And then we have that constant. Plus constant of integration when time is 0. This is our y value. Sorry about that. Our position in the y is going to be our height. So hell yeah. And then when this is going to be 0, you know, 0 is equal to this stuff. I'm going to have negative h. I'm going to get negative h over here is equal to negative g divided by 2t squared. Negatives can cancel. And I'm just going to solve for time. So this is going to be 2h divided by g square root. So that's what time is. And so for this problem, we have our height is 500. G is 10. And we have this. So we have 1,000 divided by 10. That's the square root of 100. And then that's going to be 10. So we have time as 10 seconds. So that's without air resistance. So that would be kind of the simplest problem to do. And you might just have memorized this equation because you're doing tests like this. I mean, I think the fastest way I would get there, because I don't try to memorize, I'm just like saying, I would say acceleration is negative 10, v is negative 10t, position in the y is negative 5t squared, and I want to, and I'm just going to assume position is a starting point of 0, and then we're going to go 500 meters. That's the same thing as dropping off a cliff at 500 height going to 0. And then so I'm just going to say time is oh, well, yeah, I would have to throw 500. So I would have 500 divided by, oh, I see where I'd probably drop the negative. And, yeah, no, you got to keep all that stuff. But anyway, 500 divided by 5 square root. That's what I would have for time. and that's just square root of 100. Yeah, negatives suck, man. Because, yeah, this equation would say I'm accelerating -10. My position is going to be, if I'm setting that as my origin, my position is going, I'd have to set my y as -500. So then I would have -500 on that side is -5t squared. The negatives cancel. This becomes 100. T is equal to t squared, and t is equal to 10. All right. So, from an approximation standpoint, where's my little card on approximation? Alright, hell yeah, I lost my card, but that's fine, because we wanted to do this, so we know that time 10 should get us fairly close. And so, what I'm going to do is use this equation right up here. So we're going to use this equation, and we're going to throw in 10. So I'm going to do y at t is equal to 10 seconds. And that's going to be -g c2 e to the -c10 minus gc10 plus gc squared plus h. Where h is 500. And so yeah, let's write this out, I guess. So we have y10 is -10.05 squared e to the -0.05 times 10 minus 10 divided by 0.05 times 10 plus g divided by 0.05 squared plus 500. Now the parentheses are the only place where I inputted that time, because we're going to get this value and then we're going to do the same thing for y11. Now in this test you can use calculators to do that. So that's what I would do. And then we're going to do a linear approximation. So let's just throw this in as we would. We were going to do -10 divided by 0.05 squared, alpha e to the -0.05, parentheses 10, minus 10 divided by 0.05, and then, Alright, so minus 10 divided by 0.05, parentheses 10, plus 10 divided by, this is 10 divided by 0.05 squared plus 500. Hell yeah. So we get a value of 73.9 meters. So after 10 seconds, it's not at 500 meters, it's 73.9. After 11, so you would go back in here and switch the 10 for 11. And in the comments, is there any other way to do, I'm sure there's a lot of ways to do approximations. But if we throw in 11 seconds, we're at -8.00 meters with the significant figures. So after 10 seconds, after 11 seconds. So we already know that it's going to be between 10 and 11. So time is, that could be your approximation. But I love linear, what do they call this? Linear approximation? So we have this range between 73.9 and -8. So find the difference between that range. That's going to be -8 minus 73.9. Cool. And then what value do you want? I want 0. Okay, so as it goes 0 minus 73.9. That's going to be the proportion. So if here's like the range of values between there and there, I just want the proportion of it. So it's pretty substantial. Like this is going to be like -80, and then this is going to be -70. So that's almost like 90% of the range, so keep that in mind. Okay, hell yeah. And we're going to take that proportion, that ratio, so I might just do that ratio, and then we have the time value between 11 minus 10. So, and we want to know what time it is. Let's say it's 10.85 or 10.8, 10.9. We just don't know. Okay, so hell yeah, we're going to take the difference between. This is just 1 second, and then we're going to add it. So we're going to go 10 plus this proportion multiplied by that distance. So this is just the linear approximation formula. And this is going to give me the time. And so we're going to have 10 plus, and this literally comes out to 0.9, but let's do it. So we have 10 plus negative 73.9 divided by negative 8 minus 73.9, 11 minus 10. And we get 10.9, and there's your approximation. So hell yeah. So definitely, I think hopefully under 30 minutes on this one, we'll see. But finally did it all the way through. I did it in 10 minutes, and this was a little bit longer. But now I don't think I'm done with this, because you can still go through and yeah, it's kind of fascinating. Kind of just figuring out things from intuition. Alright, but we're going to be done with this one. Thanks for joining me. Hell yeah.